Hello, welcome to the stream. It's Saturday, the 12th of December, and the 12th day of Advent of Code. Usually I do these in the early morning for me. I get up very early and sort of try to get them out of the way before I start with the rest of my work. But today it's Saturday. I took it a little slower, went for a nice long walk. And so instead of doing this while the sun is rising in Berlin, I'm doing it while the sun is setting in Berlin, which is apparently 20 minutes to 4 p.m. this time of year. Right. I'm just going to straight up dive into today's puzzle. Yesterday was interesting, I guess, in many ways, but I feel like the puzzles are starting to get to the point where they take long enough that if we just talk about the puzzle of the day, that the stream already runs close to an hour, which is really where I like to cap it. So I'm just gonna dive straight in and see how it goes. Part one of today does not look too bad. Here we are. Remember to switch this time so my post-it can go aside. A couple folks on the stream do drop into the chat. It's nice, like I put up the video afterwards, but it's a good feeling to know that I'm doing this with some folks who have my back, and sometimes it's really helpful that we can sort of look at something together and you can point out my typos, stuff like that. So I'm going to start with the demo input. Let me quickly walk you through today's puzzle. It's basically turtle programming. I don't know if you guys are aware of the work of Simon Papert, or however you pronounce it, Papert. He's done this Logo programming language, and one of the typical things you do in Logo is control a turtle. You give it instructions of how to move. And it's sort of a nice, very, very tangible way of getting started with programming. Today we're basically doing that. Our puzzle input is, move forward 10, move to the north 3, move forward 7, turn right by 90 degrees, turn forward 11. So these are the different instructions that we have. Interesting to point out is that we have absolute motions, so we move north, south, east, west, and then we have these kind of relative motions where we go left or right or forward, based on we go forward based on where we are currently facing, and then with left and right we can change the direction we're facing by a certain number of degrees. And here it shows 90 degrees. And I'm actually going to go and fetch our puzzle input for day 12. And kind of have a look at I'm guessing we're only gonna have to deal with multiples of 90 degrees. I sure hope so. Let's do a sort unique on that. Hi Nazar, also hi Mitesh. Cool to see some folks around. Yeah, so left by 90, 270, or 180, so that's kind of that's cool. We only have a number of cases to consider. It would get a little funky if they would make us move by 45 degrees and stuff like that. So that's nice. How big is the puzzle input? 200 lines. Okay, yeah. I don't think we're gonna have performance issues today. But you never know. In part two, sometimes it gets hairy, like we saw yesterday. Actually, yesterday I ended up spending a bunch more time trying a different approach and it did not work. I spent a lot of time on it, and my alternative approach, which you can find in the repo, Puzzle 11 Alt, kind of tried something different here, tried various performance tricks. It was still slower than my first solution. I did afterwards go back and sort of port it over this kind of hacky optimized lookup in nested vectors, which does not do boundary checking, so you're going to get exceptions if you're out of bounds, stuff like that, but it just, it is kind of the fastest you can get, and that did speed things up significantly. So my final solution was 500 milliseconds for part 2, which, looking at what people were saying in Clojurians on the Advent of Code channel, was pretty good. So all in all, let's say that was a success. I'm going to make a variation of our num resource seek function, utility function. So we have a utility function for reading in a file and just parsing all lines as numbers. And I'm going to make a variation of that where we give it the data we're on and a regular expression. Maybe swap these. Find regular expression string, right? Yes. And then drop the first one so that if we have capturing groups in there, that it only takes the capturing groups. Basically what that looks like, well, okay, in this case, let's first add some and just do it by hand this time. What do we need? We want Clojure string, and we want our util namespace. I guess I can also enable keycast mode like yesterday. It's not perfect. I feel like it doesn't really clearly tell you for these Vim style comments what it's actually doing, but it should give folks some indication. Okay, so basically, why did I just create this helper method? So that I can do this word character, number of digits characters. Let's just take 10 of these. Right, so that kind of makes it nice and easy to read in a sequence and parse each line with a regular expression. But we'll have to start with pattern, parsing our demo input, string split lines of the demo input, map, and I guess do the same thing here. Next, reseek pattern input line, pattern, reject string, right? Reject string, string split lines. Huh. Yeah. No, wait, where am I? Oh wait, this is a seek of, why is there that extra nesting? And now we just map over each. Oh, I'm using reseek and not refind. Sometimes these regex functions, they all start with re. They're so easy to confuse them. Right. And then I guess instruction and number, maybe. Instruction parse long, util parse long, number. Okay. Already it's weekend. My brain is half shut off, but I think today's will be easy enough. Yeah, we just, the main thing is to encode these rules, right? Because then I think we can just sort of do a straightforward reduce. And I could use maps, but I'm just gonna do it. What reset is enough. I'm not sure if I got the reference what that is referring to. Are you talking about reset on an atom or resetting your REPL? Okay, so demo parsed, right? Right. And so our starting state, reseek. Yes, reseek is, I guess, all you need. But sometimes I don't want reseek. Refine is fine. X is 0, Y is 0, and we are starting out east. That's what it says in the description. Handle instruction. And let's call it IN and just do a case. Let's see how far we get with just a pretty naive. So yeah, we have north, east, south, west, left, right, and forward. And let's give it the state first. That'll work nicely in a reduce then. So we have X, Y, and direction. So if we go north, let's say that X goes, positive X means going north, negative X means going south. And so positive Y means going east, negative Y means going west. So in this case, everything stays the same except X. And here, everything stays the same except Y. And then going south is the opposite of going north, and going west is the opposite of going south. Going forward, we can kind of cheat, quote unquote, and let's capture this so we don't need to rebuild it as state. So it just means the current state going in the current direction by the same amount of steps. And then we have left and right, yeah? And I mean, looking at the instructions we get, there's really only 3 options here, 90, 180, and 270. So N is going to be 90, 180, or 270. Am I just gonna hard code these? Maybe I am. So if we're going north, now we're going east. If we're going east, now we're going south. If we're going south, now we're going west. And if we're going west, now we're going north. Boom. Nice and easy. And then Clojure set has this, I forget what it's called, but there's a utility function in Clojure set for like sort of flipping the keys and the values in a map. Map invert, is it this one? So if we're going east, now we're going north. If we're going north, now we're going south. If we're going south, then yeah. If we're going north, now we're going west. Yeah, that looks about right. So this is the one for 270. I mean, going 270 degrees to the left, I guess, is the same as going 90 degrees to the right. X, Y, same thing here. And then 180 is just flipping directions, right? So north becomes south, south becomes north, east becomes west, west becomes east. This all makes sense, right? Like folks on the stream, please tell me if this does not seem like a reasonable thing. I'm pretty sure there are smarter ways to encode this whole thing, but I think this is actually going to be, like, performance-wise pretty good, and I think it's still not completely unreasonable. Okay, here, does it make sense? Can I just swap these around? I think I can, huh? Like if you go 90 degrees to the right, that's the same as going 270 degrees to the left. 180 degrees is 180 degrees. That's a U-turn. That's the same for both of these. So, yeah. I think we got that. Let's reorder these just for aesthetic reasons, really. I'll leave that here in case folks want to see what I was doing. And then with that, I think we can say reduce handle instructions start demo parsed. No matching class 10. What? We are not matching on the instruction, we're matching on the number. That is not what we want to do. 1417 north. Is that what we are expecting? At the end of these instructions, the ship's Manhattan distance from its starting position is 17.8. Ha! Okay. Something is not quite right. So let's do it step by step. Yeah, let's just print this out. So here's what's happening. East, 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 east. Is everything going east? F, N, F, R. Oh yeah, no, we're still, yeah, east is the direction. Let's actually print both of these so we also see what we're doing. So this is the state before, and then the instruction that we're about to execute. So, okay, this is already problematic because we're starting at 0, 0 east. We're processing forward 10. So why are we still at 0, 0? East. X plus y plus n. Does anyone see it? Oh, because I'm just returning that. That is correct. That is my new state, my three element tuple, my triple, so to say. Yeah, a little trick if you just want to sort of print out a value of an expression while still returning the same value of that expression. You can do a do to prn. And of course now we can't recur from tail position, or we're no longer in tail position, but I can just turn this into plain old. Oh, yeah, dn, yeah, no, that is correct, huh? Oh, why is it only printing out? Okay, something about my flow is weird. I'm missing something fundamental here. State, process this instruction, and then the result is result, and we return result. Well, yeah, we're handling a forward, which means handling east 10. Oh yeah, no, it does make sense. It does make sense. It's the recursion that is kind of changing the output to be a little less obvious. Okay, let's look at that again. So, yeah, going east 10 brings us to 0, 10, which is because we went forward 10. Going north 3 from there brings us to 3, 10. Yeah. Going east 7, 3, 17. Going forward 7, we're still going east, so that brings us to 3, 17. Right 90, we were going east, we turned 90 degrees to the, oh, I'm flipping my right and my left, is that it? If I'm east and I go 90 degrees right, I should be going south. Yeah. The other left. Minus 8, 17, 17, 8. Yeah, we need to do take the absolute value and then compute the Manhattan distance. So Manhattan distance in a two-dimensional plane basically just means you take the vector, you take the absolute value of the length in the x dimension, the absolute value of the length in the y dimension, add those two together. I guess it's kind of a simplified or inverse Pythagoras kind of thing. I mean, they're calling it that here to be fancy. But yeah, basically this is just what we want. Take the absolute value of the 2, add that up, and let's destructure this, and we can pass our results straight through. Let's just call that Manhattan. That should say enough. Manhattan 25, and that is what we expect. If we do the same now for real parsed, yep, looks good. Yeah, so the Manhattan distance, put that in there so we know what we were getting. And then on the real input, 1589. 1589. So far, so good. Now, what are we getting for part 2? Almost all of the actions indicate how to move a waypoint, which is relative to the ship's position. So we're not moving the ship's position, we're moving a waypoint. To rotate, yeah, so this is all the same thing. The waypoint starts 10 units east and 1 unit north relative to the ship. The waypoint is relative to the ship, that is, if the ship moves, the waypoint moves with it. For example, using the same instructions as above. F10 moves the ship to the waypoint 10 times. Okay, so north, south, east, west moves some, basically a point in the space that we're moving towards, in a sense. L means to rotate the waypoint around the ship left to give a number of degrees. Counterclockwise. Action R means to rotate the waypoint around the ship. Or around the ship. Right? So it's kind of relative, it's all relative to the position of the ship. So F10 moves the ship to the waypoint 10 times, a total of 100 units east and 10 units north. So, okay, the waypoint starts at 10 east, 1 north. So in our encoding, that would be 110. And so F10 means that you're basically applying that vector 10 times. N moves the waypoint. So what they're calling a waypoint, I guess, is really just sort of the vector that we're applying to the position of the ship. Yeah, so north. Let me put these side by side. No, like this. And see if we can get to the same results. So the waypoint starts 1 north, 10 east. And does it have a direction? No, not as such. It's just a 2-element vector. So that is its direction in a way. So this is 110, yeah. And then we have F10. And our ship, actually, waypoint start is 110, whereas I guess the ship start is still the same. 00 east. Yeah, so let's just make sure we understand this so that we're not doing the wrong thing. So we start with the ship here and the waypoint here. Now we process F10. So we apply this vector 10 times to our current position, or we add 10 times this vector to our current position. So we're at 10, 100, still going east. Well, east in this case no longer really matters, I guess. We're at 10, 100. And the waypoint has not moved. It's still at 110. Then we go N3. Moves the waypoint 3 units north to 10 units east and 4 units north of the ship. Alright, so leaving the ship. Stays at 10-1. Yes, so north 3, so our ship is still in the same spot, but our waypoint is at 410. 10 east, 4 north. Ship remains at, yeah, so our coordinates are flipped compared to theirs, but that's fine. F7, forward 7, so this is the vector now. 7 times 4 is 28, so that's 38, and 10 times 7 is 70, is 170. 170, 38, yes. Okay, so I think starting to get the hang of this. Waypoint stays. And then we need to do the rotations. Rotates the waypoint around the ship clockwise 90 degrees, moving it. So yeah, now we're sort of applying this rotation to that vector, basically rotating it around the 0, 0 axis. I ordered a second webcam just because this webcam sucks, but I was also kind of excited to have a second webcam so I could point one at my desk and kind of show you some scribbles. I feel like this would be super helpful because this is really like, this is straight up vector math. But okay, you know, you'll have to take my word for it. So when we rotate 90, we rotate the waypoint, so this stays the same. And this guy, I mean, if we're kind of at, you know, 410, and then we rotate counterclockwise, it's sort of, we're at 410. And then we're going to be at, well, this is 410. That means that we're going to be at minus 10.4. Is that right? So we put our ship clockwise, moving it to 4 units east and 10 units south of the ship. Yeah. 10 units south, so that's minus 10, 4 units east. Okay, okay. I think we got this. Because then we go forward 11 again, which means that plus 38 times 11 minus 10, and then plus 170 times 11, 4 is minus 72, 214. So 214 east, 72 south. Yeah. Cool. So, how shall we do it this time? Whoa, not so fast. So, yeah, I got my XY position of the ship and my XY position of my quote-unquote waypoint. So this is the state that we're going to thread through the reduce is going to be this two element vector of two element vectors. And so these are fairly straightforward. because they only change the waypoint. Actually, can I handle 2? I'm gonna keep these around for reference. Let me also comment this out. So yeah, north means positive x, so plus wx and y. Whoa. Come on, what's happening today? There you go. So this we add to x. Here we subtract from x. Here we turn it around. We add to y. And here we subtract from y. So that's for northeast, southwest. Forward is a little different this case, but I already demonstrated it here basically, right? So forward just means, yeah, our waypoint stays the same, but here we take our current x and apply the waypoint x multiplied by the number, and then our current y plus the waypoint y plus the number. Yeah. And then let's do these folks. Let's first go clockwise. So that's to the right. And here, I'm just gonna So this is kind of what we're working with, right? And so if I turn this 90 degrees to the right, then my new x is minus y, and my new y is my old x. Does that make sense? I hope that makes sense. And I hope that's correct. So in this case, again, this doesn't change our position. It only changes the waypoint. And it changes it, turning the x into the negative of the old y and turning the y into the old x. And I can continue like that. I mean, 180 is 180, just means basically, you know, take the, multiply the vector with -1 in a sense. And then 270 has to be the third option, where we flip x and y and take the x for, is that right? Haha, thanks. Yes, switch to code. Okay. See, I really need you folks on the stream, or I would just mess up repeatedly. So 270 right means 90 left, which means that my x is my old y, and my y is negative of my old x. Yeah, that's what I have, right? So this is kind of what we're dealing with. And if we know that, then we can do the left, because I mean, it's really just I mean, 180 to the right or 180 left, it's just a U-turn, like we said before. 270 right is 90 left, 90 and vice versa. I think that's I think that's it. I think that's our new handle function. Oh, have I messed up something here with my nesting? Oh, I accidentally deleted the closing parenthesis here, I think, with this copying and pasting. Same here. Yeah. So, what happens if we reduce handle 2, and then a starting position is, you know, our old start, or really just 0, 0, and then waypoint start. And then let's do that over demo parsed. After this operation, the ship's Manhattan distance from its starting position is 214.72. Okay, that's clearly a different result than what we were expecting. So let's start debugging this, and here this will come in handy because we've already kind of played out this scenario. So I am just gonna make this print out exactly this format. Let's do the same thing, get the result from this operation, and then say print instruction number, and then x, y, w, x, w, y. So that's kind of neat. We basically have a test case that we can test against. Run that. Oh, I need the return res, of course. That's why I'm capturing it. 1 second. I'm printing the old ones. First res, second res. Sure. Okay. So F10. We started 1000, 110. Okay. And 3, 1000, 400. Where is that 100? Oh, I think, did I swap a WX and an X somewhere? North 3, yes. I need to move my waypoint. Shouldn't mess up my regular X with my WX. Yeah, the rest looks fine. Let's try that again. 72,214, 72,214. Yes, that is what we were expecting. Let's take this out again. Right, so that's our handle 2, which means that now we can do this for the real parsed input and call Manhattan on that. Oh, wait a second. There you go. 26988. 26988. Submit. Oh, your answer is too high. Okay, so what are we doing wrong? Let's try again. So for the demo input, demo parsed 286. And that is, that is correct. After these operations, just figure out where the navigation instruction actually lead. What is the Manhattan distance between that location and the ship's... Ah, wait, what? And the ship's starting position. Well, the ship's starting position is 0, 0, so the Manhattan distance is that number, right? That's... I don't think we're doing that wrong. Are there instructions that are not used in the demo input? So, okay, I think our forward, north, and right 90 are probably right because, you know, we get the right result with those. But how about the rest? And how do we test that? If anyone has any suggestions on how to proceed, I'm all ears. Let's okay, first of all, let's actually do this a little bit smarter in terms of debugging this stuff. State. Let's see. Now let's make this, because I want to have access to both. Let's make this a decorator. Fn pos w pos in let res f. Let's just say state in print line string in first res, second res, res. So we can kind of easily say, let's just take 20 of these and decorate our handle2 function. Actually, let's use a format. Just want to have this look a little nicer. Yeah, all right. Let's clear that. So we start, position starts at 110. We do a U-turn. Waypoint now is at -1, -10. We go south 4, which moves the waypoint 4 south. Go left 90. If we're at -5, -10, so that's in this third quadrant, we go left, so counterclockwise 1/4, then no, left. Yes, counterclockwise in the third quadrant. Now we're in the second quadrant where x is negative, y is positive. That seems right. South 2 more south, right 90. So now we're back in this quadrant. West 3. Oh, is that right? West. East increases y, whereas going west should decrease y. I think it's about a rotation. The axis on the map is different that you draw on paper. Can you elaborate on that? But I feel like something's wrong with our west here, because we said that east-west is the y-axis, and going east increases y, and west decreases y. So if we're at -5, -12, and we go west 3, we should be at -15. Here you go. God, what an annoying bug. So we had a WX here instead of a WY. Maybe, hopefully, possibly, that's all. We got a lower number. We are supposed to get a lower number. So let's try again. All right. All right, and we managed to finish under the hour. Hope that was fun. Yeah, not too horrible of an exercise. And I thought it actually. So I've been toying around with some Minecraft stuff. Yeah, thanks, Felipe. Live stream is, I guess, running behind a little bit. So yes, figured that out, that I had a WX here instead of a WY. Curious to see what other people come up with. I think there are, like much sort of nicer ways to encode this information, perhaps, or sort of more data driven. But I mean, in this case, this does the trick, and it's pretty fast too, I think. Let's see, how long do we take for this? I mean, it's only 200 entries, so yeah, even with all the printing, we're spending 3 milliseconds. And yeah, of course, if you take out the printing. So yeah, that's cool. We got our 2 stars. Hope everyone has a nice weekend, and probably gonna stream around the same time tomorrow. So yeah, if folks in the Americas like Felipe want to catch the stream for a change, they can. So that's cool. So thanks a lot. It was nice to see some folks on the live chat. I'll be pushing the code soon. It's still at GitHub Lambda Island AOC 2020. We hang out in Clojure Slack, in the Lambda Island channel, and in the Advent of Code channel, so you can find us there. And yeah, see you tomorrow.